Hello all. Today we are going to look at implementing retrieval augmented generation, which is a RAG architecture for enhancing the LLM knowledge base. Okay, first we'll look at a quick architecture overview of the RAG model. Okay, so this is a RAG architecture. So a client, when he asks a question, the question doesn't go to the large language model directly, but instead it goes to a database. So this database is a local database which hosts all the new information. So the framework routes the question first to the vector database, and the vector database returns relevant information associated with that question. Okay, that is called as contextual data. So the framework again takes the question and the contextual data, and the question in the sense the prompt and the contextual data. It combines these two and it sends that information to the large language model. So the large language model looks at the prompt and it understands the contextual data and it generates an answer for the prompt using the contextual data and sends the response back. So the response is again retrieved by the framework and is given to the client. So this is the overall architecture where we use an external database and enhance the knowledge capability of large language models. So we will see how to implement this architecture in using AWS Bedrock now. Okay, so this is the code which explains the usage of RAG architecture in the using Amazon Bedrock framework. Okay, first thing we will import and install the packages that are needed for implementing this architecture, and then we will load those libraries which are needed for our execution. So this is the prompt template. So use the following piece of context to provide a concise answer to the question. Okay, but we are asking it to use only the contextual information that we provide and not to make up any answer if the LLM doesn't know the answer. So it has to use only the context information that we have sent and then generate the answer. So that's the template, that prompt that we are asking it to use. And then the Bedrock Boto3 client, we are initializing the Bedrock client, and then we are going to use the Bedrock embedding using Amazon Titan text1 model. So this is an embedding model that we are going to use. So I already got access to the Titan embedding model. So this is the Titan embedding model. So this is the model ID. The same model ID is what we are using here. Okay. The next activity we are going to use is to load the external data and split the data into different chunks. Okay. For this project, I used Synchrony's latest con call that happened recently on the annual report or the earnings actually. So if you see, this is the con call where the CEO of Synchrony, Brian Doubles, has explained the answers, as well as our CFO, the Brian Wenzel, also answered several questions explaining how we have performed in this quarter. So these are all the details. So if you see here, we see the explanation that is given by Brian Wenzel on our earnings for this quarter, how the numbers look like, where we performed well, where we did not. All that stuff has been explained, and there in the later part of this discussion, there are some questions also being asked by the persons who joined the call. So there is a question and answer where people asked several questions, for which Brian Doubles and Brian Wenzel has answered the questions. So this is all the transcript of all that information. Okay, so we'll use this as an external source of information, and then we will get answers on this piece of information. Okay, that's the whole idea. So we will load the PDF document. Okay, and then we will split that document into different chunks so that the context size will be sufficient enough to hold the chunks of information. Okay, and then we will use the FIASS vector store library. So the FIASS is a Facebook AI similarity search open source framework that is used to embed the data. So we will use this open source architecture, and then we will create embeddings for the data that we have used in the PDF. Okay, in this piece of code we are initializing the LLM. So the LLM that we will use is Mistral 7B. Again, this is from the Amazon AWS Bedrock. Okay, and then we are going to use this as the prompt template. So now in this section of the code, we'll combine all these together. So we will use the retrieval QA to combine the LLM and the vector store. So this takes user's query as an input and retrieves the relevant information from the vector store, and then it sends the data to the large language model. Finally, we will create a user interface to combine all these things together using Streamlit architecture. So the Streamlit is a nice and easy way to build web interfaces for the architectures. And so we are going to use the Streamlit library where the users can interact with the RAG system and then they can get the answers back. Okay, so this is the overall framework. So let me execute this code and then show you how the results look like. Okay, I'm executing the Streamlit code. So this will open up a local instance where we can see the results of the execution. Okay, so the Streamlit application has started, and it will open up a web interface where we can see the options of building the RAG architecture framework, as well as we can ask questions and get the response back. So this will take just a minute for it to load. So okay, so here if you see, we have two buttons here where we have used store vector and send buttons available. So the store vector, what it does is if we click this button, it will store all the data which is there in the PDF document into a local FIASS embedding database. Okay, so if you see here, I won't click this store vector because it will take 2 to 3 minutes for generating the vector DB. But I already completed this activity and I will show you how it looks like. So if you see here, there is a folder that is created called FIASS local. Okay, this FIASS local is what contains the embedding of the PDF document. So we have divided this PDF document into several chunks and created embeddings for those chunks. So all the data will be stored in this FIASS local DB. So let's ask a question, okay, and then see how the response looks like. Okay, so this is the question that I am asking the RAG framework. So please summarize Brian Double's answers in less than 100 words. So what it does is, first step, it goes using, if you see, so the question, I asked this question, so it goes to the vector database. Vector database returns relevant information from the chunks of data, and then that relevant information along with the question is passed to LLM, and LLM generates the response and gives back. So if you see here, this is the information that we got back. So the president and CEO stated that competitors are likely to follow similar strategies in response to their PPCC efforts. So this is a summary of all the information that Brian Doubles has mentioned in the question and answers as well as in the meeting. So this being the latest information, the large language models doesn't have an idea of this information. So we are augmenting that knowledge base of large language models using the vector database, which is an external source of information. Thank you all.